Everyone, my name is Marina Baker, and I will be speaking on chemical reactions today and about one reaction in particular. So the purpose, we experiment with chemicals and we find the result of the chemicals because it tells us how certain chemicals mix with the other chemicals and what they can do, and it tells us what chemicals are capable of. So the purpose of this experiment was to identify polyatomic ions and spectator ions, and we also found out how to predict certain products of chemical reactions, and which we verified our products with the reactions in the lab. Chemical reactions also help us understand certain aspects about chemical reactions and what chemicals can do. So in the lab, we created 4 chemical reactions. We mixed sodium chloride with silver nitrate, calcium chloride with aluminum sulfate, calcium carbonate with hydrochloric acid, and sodium hydroxide with hydrochloric acid, and phenolphthalein was added as an indicator, which the reaction I'm most interested in is the sodium hydroxide with the hydrochloric acid. So phenolphthalein, which we used as an indication in our lab, is also used in an experiment done by the National Library of Medicine, and they did an experiment on disappearing inks. What they did was they applied different amounts of the phenolphthalein to different handwriting on different textured papers, and when it was just the phenolphthalein, the phenolphthalein enhanced the handwriting. But when the phenolphthalein was mixed with sodium hydroxide, the ink disappeared, which is sort of the same reaction we got whenever we experimented with it. So the sodium hydroxide was mixed with the hydrochloric acid and phenolphthalein. The sodium hydroxide and the hydrochloric acid solutions were clear to begin with, and whenever the hydrochloric acid was added, it had a dust cloud of pink because of the phenolphthalein, and it indicated that there was the base present. So we had to prepare the sodium hydroxide solution and the hydrochloric acid, and by doing that, we had to, for the sodium hydroxide, we figured out that we needed to use 10 milliliters of sodium hydroxide in a 50 milliliter volumetric flask, and we also did that. We did the same equation for the hydrochloric acid. So what we did, we put the sodium hydroxide into a beaker, then we added a couple drops of the phenolphthalein, and then we slowly poured in the hydrochloric acid. Both the sodium hydroxide and the hydrochloric acid were clear to begin with, but as soon as the hydrochloric acid entered the beaker, it turned a little bit of pink. It turned pink because it indicated that there was the acid base present, but once that settled, it was colorless. So the reason it turned colorless was because the sodium hydroxide and the hydrochloric acid basically turned into salty water. The sodium and the chlorine formed sodium chloride, and the hydroxide and the hydrogen formed H2O. And there's the equation there. That's why our solution turned clear. And then those are my sources. Thank you.